Hello all. We are going to see another way how you can write or identify whether a given number is prime or not. For that you need to know a very simple rule about the prime numbers. The first rule to identify whether a given number is prime or not, you will find the number of factors. If number of factors is equal to 2 only, then it is a prime, else not a prime. Okay, this is the first property that you can use and write a program, which I have already explained in the previous video. Now coming to the second property, that is, this is more efficient. First one is bit tedious because you need to divide a number so many times depending upon the value of num, right? For example, if you take num is equal to 100, you go on dividing 100 by 1, 2, 3, 4, 5, so on till 100. So you will require so much time to identify whether 100 is a prime or not. But the second method that I am going to tell you is going to be very efficient, but not the most efficient. I will discuss that also in the later videos. But let's see what is the second method. Now let's imagine that you are given a number. Okay, let that number is 5. Whenever you divide this 5 by 1, you are going to get the quotient as 5, right? You cannot divide by 2, not by 3, not by 4, and again by 5, and you are going to get 1 as a quotient. So if you leave all this and only take this 1 and 5, it is having only two factors, and therefore you can say that it is a prime number from the previous step. But now what we are going to do, now let's take num is equal to 6. We are going to check from 2 if it is divisible by 2 to 6 by any other number, excluding 6, then I can consider that this number is a prime. For example, if you take 6, 6 is already having 1 and 6 as the factors. You need to identify one more factor which is not 1 and 6. Which is not 1 and 6. For example, if you try dividing it by 2, after 1 you are going to get 2. If you try dividing it by 2, then if 6 is divisible by 2, then what we can say, that 6 is not a prime number, right? Now if you take num is equal to 9, in this case also we know already that 9 is divisible by 1 and 9, right? So we will try to find another number which is between 1 and 9, which can divide 9. Okay, now if you take 2, 2 cannot divide 9, so we'll exclude it. If you take 3, 3 can divide 9, and straight away I can say 9 is not a prime number, right? If you take another number is equal to 14. Okay, if you take number is equal to 14, already we know that 1 and 14 are the factors, and I am going to find one more factor between 1 and 14. So if you can check with 2, yes, it is divisible by, so straight away I am going to say that 14 is not a prime number. Now similarly, number is equal to 17. If I take number is equal to 17, already I know that 1 and 17 are the factors of the given number. Now you go on checking to no. Is 17 divisible by 3? No. Is 17 divisible by 4? No. The same way, if you check with any other number till 17, you find that 17 is not divisible by any of the numbers. Therefore, 17 is a prime number. Okay. And similarly, we are going to take another example. Num is equal to, I can take like 11. See, whenever you are checking 11 is prime number or not, you are not going to check till 11. You are going to check for 2, 3, 4, 5. If it is not divisible by 2, 3, 4, 5, then it will not be divisible by any of the number after 5. Because, see, if you consider 14, you have got 1, 2, 7, and 14. This is divisible by 7 because it is divisible by 2. After 7, 14 will never be divisible by any of the numbers. Can you observe that? It is the case with all the numbers. And so we are going to exploit this particular property of numbers to identify whether a given number is prime or not. Okay. So for that, what we are going to do? Just I am going to write the program. Observe carefully. Hash include stdio.h. This is for using standard input output like console and the user inputs. Now int main. In this we are going to consider some variables like I need a number to take input. Then I need a flag. Flag can take only two values, 0 or 1. There is a difference between a flag and a count. Count can take values from 0 to infinite, but flag can take only two values. This is just used to just it is a real life flag actually. If you raise a flag, it means something. If you don't raise a flag, it means something. Means there are only two states in the flag, that is 0 and 1. You need to remember this. You can use this flag in any of the programs. So 0 and 1, so I can say that it is an integer. I have got an integer num and a flag. Okay, flag initially I will not rise, so I'll make it 0. If you rise the flag, it means it is 1. If you don't rise the flag, it is 0. Okay, and now what I am going to do is I am going to say the user to enter a number, because if you want to check whether a number is prime or not, first you need to take the user input. So I am going to take user input, then scanf %d ampersand num. Okay, now if the number is like 14, I need to divide this 14 by 2, 3, 4, 5, 6 till 7 if you want. If it is divisible by any of the one number among this, then I can directly say that it is not a prime number. So what I will do, I'll run a for loop which will have int I is equal to 2. See, I am going to start this loop from I is equal to 2. Then I am going to end I is less than or equal to num divided by 2. Okay. Then I plus plus. This is for incrementing each value. Now here I'll put a condition. If given number is divisible by I, this is the condition. If the number is divisible by I, then I am going to raise a flag This is going to assign flag value as 1 and then break the loop. Okay, then after that I am going to close the loop. Now see, after this I'll just put a condition. If flag is equal to 1, if the value of the flag is 1, then printf the number is not prime. You saw, if the number is divisible by any of the other numbers like 2, 3, 4, 5, 6, 7, then it is not a prime number. Okay, else printf the number is prime. That's all. This is actually the program for the identifying the user input is prime or not. Now we'll go for execution. Already I have written the code and which is almost similar. Now let me explain this code once again. Okay, now we are going to see. I have written int main. Here I have got a num. Either you can say I here or you can directly int I. Anything is okay. Before using I, you need to say what is I. That is the important thing that you need to follow. Then a flag which is already initialized to 0. Now we will ask the user to enter a number. Now if the user gives num is equal to 7, then what we are going to do, we are going to run a loop from 2 to 7 divided by 2. It is equal to 3.5, right? But we'll, since it is integer, we'll consider only till 3. So we are going to divide this 7 by 2 and 3. See, in the initial stages 7 will get divided by 2. If it is not divisible by, it will go back, increment I will become 3. Then 7 divided by 3 is equal to 0. It is false. So again it will go back, increment I is equal to 4, which is going to make our statement wrong, because the condition is I should be less than or equal to num divided by 2. It means 4 is less than or equal to 3, this value. So this is not right. So this is not right. That's why it will exit the loop. It will check the flag value. Since the flag value is not changed, we are going to get to else statement and execute this one. Okay. Now let's take another number. Num is equal to 9. Okay. Let me take another pen. Num is equal to 9. Now can you tell me what is num divided by 2? This is equal to 9 divided by 2. This is equal to 4. Now what we are going to do is, we are going to run the loop I is equal to 2 to I is equal to 4. Now we'll check for I is equal to 2. 9 divided by 2 is not divisible by. So there is an increment, I will become 3 and go back to the loop. 9 divided by 3 is equal to 0. Yes, it is true. That's why what is going to happen is, it will enter into the loop. It will make the flag value as 1 and it will break the for loop. When the for loop is broken, directly it will come to line number 15 and it will execute this. Since the flag value is equal to 1, it is going to say that 9 is not a prime number. Let's execute the code. gcc prime2.c hyphen o prime2. There are no errors. Dot slash prime2. will ask me to enter a number. If I enter 9, it is going to say 9 is not a prime number. If I enter 7, it is going to say 7 is a prime number. That's all. Thank you.